This video is brought to you by mywayteaching.com.
In this part, let us solve a very simple problem. The problem is a fully loaded Boeing aircraft has a mass of 3.3 into 10 raised to 5 kg and its total wing area is 500 meters square. It is in level flight with a speed of 960 km per hour. So the first question is estimate the pressure difference between the lower and upper surface of the wings. Okay. And the second question is estimate the fractional increase in the speed of the air on the upper surface of the wing relative to the lower surface. So the density of air is given as rho is equal to 1.2 kg per meter cube. So now we should solve this problem. So first let us solve the first part of the question. The question is to estimate the pressure difference between the lower and upper surfaces of the wings. Okay. The weight of the Boeing aircraft is balanced by the upward force due to the pressure difference. So that pressure difference upward force is given by delta P, the pressure difference into area. So they have given that the pressure difference that we can write it as force, that is mg. So the mass is given as 3.3 into 10 raised to 6 kg, isn't it? And we can take the value of g as 9.8. So which is, so here they have given the value of area. Area of that wings is given by 500 meters square. So the pressure difference delta P is given by 3.3 into 10 raised to 6 into 9.8 divided by 500. Okay. Which is equal to 6.5 into 10 raised to 3 Newton per meter square. This is the value of pressure difference. Okay. So now coming to the second part of the question, that is estimate the fractional increase in the speed of the air on the upper surface of the wing relative to the lower surface. So we ignore that small height difference between the top and bottom of that wings. Okay. And the pressure difference between them is given by delta P. We know this equation, rho by 2 V2 square minus V1 square. So where V2 is speed of air over the upper surface and V1 is speed under the bottom surface. So V2 minus V1 is equal to 2 delta P divided by rho V2 plus V1. We can write this, from this equation, the V2 minus V1 like this. So taking the average speed, because they have given that value as 960 kilometer per hour, isn't it? So V average is equal to V1 plus V2 by 2. So we can calculate V1 plus V2 as 2 into they have given V1 plus V2 value as 960 kilometer per hour. So we can calculate the value of V average. So here what they have given is the, yes, that is the value of V average. Okay, this 2 will not come here. Into both the cases, if you consider single case, then it is 267 meter per second. So using the formula that we discussed just now, we can write V2 minus V1 as delta P by rho V average square, which is 0.08. So the speed above the wing needs to be only 8% higher than that below. Okay. So now let us study one of the important property of fluids, that is viscosity. Okay, most of the fluids are not ideal ones and offer some resistance to motion, and that resistance to fluid motion is like an internal friction which is analogous to friction when a solid moves on a surface. So when we consider a solid, we call that force as friction, but when we consider fluids, that analogous to that friction, it is viscosity, which offers some resistance to the motion of fluids. Okay. So this force exists when there is relative motion between the layers of liquid. Suppose we consider a fluid like oil, which is enclosed between two glass plates, as you can see in the figure. Oil which is enclosed between the two glass plates. You can consider this figure. See here, the bottom plate is fixed while the top plate is moved with a constant velocity v relative to the fixed plate. If oil is replaced by honey, then a greater force is required to move the plate with the same velocity. Hence we say that honey is more viscous than oil. Okay. The fluid in contact with the surface has the same velocity as that of the surface. Okay. Hence, we can say the layer of the liquid in contact with top surface moves with velocity v, and the layer of the liquid in contact with the fixed surface is stationary. The velocities of layers increase uniformly from bottom to the top layer. For any layer of liquid, its upper layer pulls it forward while the lower layer pulls it backward. This results in force between those two layers. So that type of force is known as laminar. Okay. The layers of liquid slide over one another as the pages of a book do when it is placed flat on a table. So that upper layer, it will move that to forward while the bottom layer will move it to backward. So that causes a force. It is similar to a book, like pages of a book when it is placed flat on a table, and when a horizontal force is applied to top cover, When a fluid is flowing in a pipe or tube, then velocity of the liquid layer along the axis of the tube is maximum, and it decreases gradually as we move towards the walls when it becomes zero. You can see that in the figure. Okay, you can see that in this figure. Okay, the velocity on a cylindrical surface in a tube is constant. So, on account of this motion, a portion of the liquid which at some instant has the shape ABCD, you can see in this figure. Okay, at some instant it has the shape ABCD, takes the shape of AEFT after a very short interval of time, that is delta t. So during this time interval, the liquid has undergone a shear strain of delta x by L. Okay, or you can represent it with small l. Since the strain in a flowing fluid increases with the time continuously, unlike a solid, here the stress is found experimentally to depend on the rate of change of strain, or we can say stress is depending on the stress rate, which is given by delta x is equal to the stress rate, which is given by delta x by L into delta t, or we can say V by L instead of this, instead of strain itself. So the coefficient of viscosity for a fluid is defined as the ratio of shearing stress to the strain rate. The coefficient of viscosity. We can write it as the ratio of shearing stress to the strain rate. So that is given by the symbol eta. We can write it as F by A shearing stress, and the strain rate is V by L, which is equal to F into L A into V. The SI unit of viscosity it is given by Poiseuille. Okay, and its other units are Newton, S m raised to minus 2, or we can say Pascal second. The dimensions of viscosity are given by m L raised to minus 1 and T raised to minus 1. Generally, thin liquids like water, alcohol are less viscous than the thick liquids like coal, tar, blood, glycerin, etc. And the coefficients of viscosity for some common fluids you can see in the table. See here the coefficients of viscosity for different fluids. It's given. Water, its viscosity in MPI, it's 1. For blood, machine oil, it's given here. So we point out two facts about the blood and water that you may find interesting. So in this particular table, blood is thicker, which means more viscous than water, and the relative velocity of blood remains constant between 0 to 37 degrees Celsius. Okay, relative velocity of blood, okay, the relative viscosity of blood, it remains constant between 0 to 37 degrees Celsius. So the viscosity of liquids decreases with temperature while it increases in the case of gases. Usually viscosity of these liquids, it will decrease with temperature, but in case of gas it will increase. Okay, so now let us solve a very simple problem. A metal block of area 0.1 meter square is connected to 0.01 kg mass via a string that passes over an ideal pulley, considered mass less and frictionless. As we can see in the figure, a liquid with a film of thickness 0.3 mm is placed between the block and the table. So when released, the block moves to the right with a constant speed of 0.085 meter per second. So find the coefficient of viscosity of the liquid. So here we have to find the value of eta. So this is the figure, measurement of coefficient of viscosity of a fluid. So the metal block, it moves to the right. See here the mass is 0.01 kg. You can see this is the mass. It is connected to a metal block of area 0.1 via string that passes over an this is pulley. Okay, and this is the metal block. So this metal block moves to the right because of the tension in the string. That tension T is equal in magnitude to the weight of the suspended mass M. The shear force F is given by T, which is equal to mg, which is given by 0.010 kg into 9.8, that is 9.8 into 10 raised to minus 2 Newton. Shear stress on the fluid is given by yes, it is given by F by A, that is 9.8 into 10 raised to minus 2 by 0.10. That is the shear stress. If you consider shear rate, or we can say strain rate, which is given by V by L. So here they have given the value of V 0.085 by 0.030. So now we should find the value of eta, that is stress by strain rate, isn't it? So after note stress by strain rate, isn't it? So that stress is given by F by A 9.8 into 10 raised to minus 2 by 0.10, and strain rate is 0.085 by 0.030. So we can write it as 0.085 0.30 10 raised to minus 3. So if you simplify this, we get the value of viscosity coefficient as 3.45 into 10 raised to minus 3 Pascal second. Okay.